Alright, so we're going to be reviewing how to find the exact value of a trig function for any angle that can be written as a reference angle of 30, 45, or 60, or the quadrantal angles 0, 90, 180, and 270. Now the angles 0 to 90 are all in the first quadrant, and they are all going to have a pattern following the way in which they are determined. The values 180 and 270 are the ends of the unit circle. So 0 and 90 are already covered here, and then we still have to do 180 and 270. So we're just going to figure out what those values are, and then we're going to use them to answer some problems. And then I'll, at the end, prove where these numbers come from so that they're not just kind of random. So first, there is a pattern from 0 to 90, because again, they are in the same quadrant. So 0 is going to be 0, 30 is going to be 1/2, 45 is going to be radical 2 over 2, 60 is going to be radical 3 over 2, and 90 is going to be 1. And that is for sine. So the sine of 0 is 0, the sine of 30 is 1/2, the sine of 45 is radical 2 over 2, and so on. Now, the cosine is the same 5 values, but backwards, so we're just going to go backwards here. So the cosine of 90 is going to be 0, the cosine of 30 is going to be 1/2, I'm sorry, of 60 is going to be 1/2, the cosine of 45 is going to be radical 2 over 2, and the cosine of 30 is going to be radical 3 over 3, I'm sorry, over 2, and radical 3 over 2, and the cosine of 0 is going to be 1. And the pattern that they're all following is this. It is radical 0 over 2, which will simplify to be 0, radical 1 over 2, next would be radical 2 over 2, which doesn't simplify, which is why it stays this value. So this is just the pattern. Radical 3 over 2, once again, doesn't simplify. And then radical 4 over 2 is going to simplify to be 2 over 2, which is going to simplify to be 1. So this is just an explanation of like a pattern that you can see from 0 to 90. Now it doesn't work after that because we are actually going to be skipping quite a few numbers in between. So like we're not going to do 120 or 150, so we can't just do 180 and 270 that way. So we're just going to get 180 and 270 now using the quadrantal angle method. So looking at the circle, for 0 degrees, the sine values are always the y values, so it's cosine and then sine. So for 0, just looking at that value over here, that y value, at that coordinate on the unit circle, it's 1, 0, so the y value is 0, so the sine of 0 is 0. Then if we go to the next point, it's 0, 1, and the y value is 1, which is at 90 degrees, which is why the sine of 90 is 1. If we go to 180, the y value once again is 0, so the sine of 180 is 0. If we go to 270, the y value is -1. And then for 360 and all multiples of 90 afterwards are all going to just be following the same pattern. They're just going to be repeating. So if we just go around the circle, it is, for y values, it's 0, followed by 1, followed by 0, followed by -1, followed by 0. And these are the same points that come up when you do the sine curve when you're graphing. Now the cosine curve, on the other hand, we look at the x values. So at 90 degrees, so let me just change colors. So at 90 degrees, the x value is going to be, at 0 degrees, the x value is going to be 1, which is why the cosine of 0 is 1. At 90, the x value is 0, so the cosine of 90 is 0. At 180 degrees, the x value is -1, and at 270 degrees, the x value is 0 again. So you can see there's two patterns to follow. One is just going around the circle for the quadrantal angles, and for all the other angles, which include the reference angles, so 30, 45, and 60 are going to be reference angles. We will be inside the triangle and leaving points around the triangle, where the reference angle will always be an angle formed by the terminal side and the x-axis. terminal side and the x-axis, the terminal side and the x-axis, the terminal side and the x-axis. So the reference angle will always be an acute angle formed by the terminal side and the x-axis. So it's always going to be acute angle formed from the central angle. So the other values can be found using these rules. So the rule for tangent is sine over cosine. For cosecant is 1 over sine, meaning it's the reciprocal of sine. For secant, it's going to be 1 over cosine, and for cosine, for cotangent, it's going to be cosine over sine, which might seem random, but that's just the reciprocal of sine over cosine, which is tangent. So we're going to go through a couple of these. I'm not going to go through the entire table because you don't really need a full table for all of these values. We'll do the tangent. We'll do tangent entirely, and we'll do 0 for the remaining ones. So for the tangent of 0, we're going to do the sine of 0 divided by the cosine of 0, which is going to be 0 divided by 1, which is 0. The sine of 30, the tangent of 30 is going to be the sine of 30 divided by the cosine of 30, which is going to be equal to 1/2 divided by radical 3 over 2. If we do keep change flip, that will be 1/2 times 2 over radical 3. The 2's will cancel out, and then we'll get 1 over radical 3, which if we then rationalize the denominator by multiplying by radical 3 over radical 3, we will get radical 3 over 3. So I'm going to write that here. So radical 3 over 3 is the tangent of 30. Now that took up a lot of space, so I'm actually going to be erasing this, but I really want you to understand where these numbers come from. There is a shortcut for this as well. The shortcut is if you have a fraction divided by a fraction and they both share the same denominator, you can just cross out those denominators. This would then become 1 over radical 3, and then we can just rationalize the denominator. Because all that's going to happen is if you have those two denominators that are the same, is they're just going to reciprocal for multiplication and then cancel out anyway. For 45, we're going to get the sine of 45. Excuse me. For 45, the tangent of 45 is going to be the sine of 45 divided by the cosine of 45, which is going to be radical 2 over 2 divided by radical 2 over 2. And we can use that same rule and get radical 2 divided by radical 2, which is 1, because any number divided by itself is 1. For the tangent of 60, we're going to get the sine of 60 divided by the cosine of 60, which is going to be equal to radical 3 over 2 divided by 1 over 2. The 2's will cancel out, and we'll get radical 3 over 1, which is just radical 3. And then for 90, we get the sine of 90 divided by the cosine of 90, which is going to be equal to 1 over 0, which is undefined. Every time you see undefined, you can think of it as just being 1 over 0. And for the tangent of 180, we're going to do the sine of 180 divided by the cosine of 180, which is going to be equal to 0 over negative 1, which is the same thing as 0. And for the tangent of 270, we're going to do the sine of 270 divided by the cosine of 270, which is going to be equal to negative 1 over 0, which no matter what you divide by, if you're dividing by 0, it is undefined. Okay, so the process for finding tangent involves knowing what sine and cosine are already. So really, as long as you know this first section of the table really well, and how to do the quadrantal angles by going around the circle, you can find all of these other values. So I'm going to do a couple of these at random just to show you some of them, so you can do the rest of them yourself. So let's say we wanted to find the secant of 0. So the secant of 0 is 1 divided by the cosine of 0, which is going to be 1 divided by 1, which is going to be equal to 1. That should be pretty easy. Let's do the cotangent of 45. So the cotangent of 45 is going to be equal to the cosine of 45 divided by the sine of 45, which is going to be equal to radical 2 over 2 divided by radical 2 over 2. Anything divided by itself is 1, so that's 1. And let's do the cosecant of 60. So the cosecant of 60 is going to be 1 divided by the sine of 60, which is radical, let me write this all out, sine of 60, which is going to be equal to the 1 divided by radical 3 over 2. So this is going to be over 1. So that's going to be the same thing as 1 over 1 divided times 2 over radical 3, which is going to become just 2 over radical 3, but we need to rationalize the denominator. So that's going to become 2 radical 3 over 3. Excuse me. Unlike when we did the tangent, where no, it didn't happen for any of the other ones. Okay, so now you can do the rest of those on your own using the same methods. Let's do 2 sample problems, and then I'll show you where these numbers actually come from. They do fit the pattern, but they come from somewhere. All right, so if we wanted to evaluate the sine of 450, so this is example 2. We're going to do it for all the values just to check, but I'm just going to go over this for 450. So I'm going to draw a circle, and 450 has an angle between 0 and 360. That is coterminal to it. So going around the circle, we have 0, 90, 180, 270, 360, 450. So it's the same thing as saying 90. So we're just going to say, what is the sine of 90? Well, the sine of 90 is going to be the y value here. So just to point out the coordinates, they are going to be, just going to use colors for them as well. So it's going to be 0, comma. So 0, comma, 1. So for the sine of 90, I look at the y value, so that's going to be equal to 1. For the cosine, well, the sine of 450 is 1. The cosine of 450 is going to equal 0, because it's the x value. The tangent of 450 is going to be the sine value divided by the cosine value, which is going to be equal to undefined. So this is for a quadrantal angle. The secant is going to be 1 divided by the sine value, which was 1, which is going to be equal to 1. The cosecant is going to be 1 divided by the cosine value, which was 0, which would make this undefined. And the cotangent value is going to be equal to the cosine value, which was 0, divided by the sine value, which was 1, which simplifies to be 0. So the answer to the originally asked question was 1, but if we were asked for any of the other values, we can do the same thing. Let's take a look at the problem number 8. which asks us to do 480, which is a very similar number. I'm just going to do all the different trig values just to make sure you fully understand how to do the problems. So I'm going to draw the unit circle. That's a really bad circle. Let's try that again. Much better. Looks like a circle. All right, so I'm going to draw some straight lines somehow, and we're going to figure out where 480 is. So this is 90, I'm sorry, 0, 90, 180, 270, 360 is going to be here. Then 450, this is 540, so 540, this is 450, 450, and 480 is going to be somewhere between 450 and 540, so 480 is going to be here. So I'm going to draw our angle to this point. Now our reference angle is going to be found at the terminal side and the x-axis. So this is our reference angle. So the distance between 480 and 540 is the reference angle. So the distance from the x-axis, which is where 540 is, and the terminal side, which is where 480 is 60. So we need to know what the sine and cosine of 60 are. So before we continue, I'm going to write an equal sign next to all of these. And I need to identify the sign of each of these values. Now, I didn't address it before, but depending on the quadrant we're in, certain functions are positive. So in quadrant 1, all the functions are positive. All the trig functions are positive. But because we're not in quadrant 1, we're not going to write, that's not relevant to this problem. In quadrant 2, only sine and its reciprocal are positive. So that means the sine will be positive, but cosine will be negative. Tangent will be negative. Cosecant is the reciprocal of sine, so it will be positive. So sine also counts for cosecant. Secant will be negative, and cotangent will be negative, because tangent and cotangent are only positive in quadrant 3, and secant and cosine are only positive in quadrant 4. Whereas if we were in quadrant 1, everything here would be positive. Now we just need to know what the sine of 60 degrees is. So if we look at the table, the sine of 60 is radical 3 over 2. The cosine of 60 is going to be 1/2. The tangent of 60 is going to be radical, well, it's going to be radical 3 over 2 divided by 1 over 2, which is just going to be radical 3. Let's do the cosecant of 60 on the table. So the cosecant of 60, oh, we have it there. It is 2 radical 3 over 3. The secant of 60 we didn't do, so we'll do it here just to have it. So that's going to be 1 divided by the cosine of 60. So that's going to be equal to 1 divided by 1/2. So if we make this into a fraction, we're going to get 1 divided by 1 times 2 over 1, which is 2. So that's going to be 2. And the cotangent of 480, which we didn't do yet, is the cotangent of 60. So that's the cosine of 60 divided by the sine of 60, which is going to be equal to 1/2 divided by radical 3 over 2. I'm just going to cancel out the 2's. I get 1 over radical 3, and by rationalizing the denominator, we're going to get radical 3 over 3. And that's how you can find the exact value of any angle, as long as its reference angle is 30, 45, or 60. All right. Now, a couple things to note is that the reciprocal of radical 3 is radical 3 over 3. So anytime you have radical 3 for one of the values, you can just find its reciprocal by rewriting it as radical 3 over 3. Same thing happens for radical 2 over 2. So where we had, for 45 degrees, we had radical 2 over 2. If we were to look for its reciprocal at any point, so like if we were to do the cosecant of 45, it's going to be radical 2. Anyways, try the remaining examples on your own. I'm going to leave out the explanation for the reference angles for now, but actually I'll do it now. So really quickly, where these numbers come from is if we take this equilateral triangle here that I've drawn with a 1 as all of its sides, I'm actually going to split it in half, and we're going to turn this into a 30, 60, 90 right triangle. And I'm going to erase the right side of the triangle. And then I'm going to put this inside of a unit circle. So this is now a 60-degree reference angle. This side measures a half because I split the triangle in half. And if I make this x, if we were to solve for the missing side, this would be radical 3 over 2 if I use the Pythagorean theorem. So the opposite side is the sine. So the sine of 60 is radical 3 over 2. The adjacent side is the 1/2. So that's where the cosine of 60 comes from. And then if we were to look at this triangle from the 30-degree angle, the opposite side is a half, which is where the sine of 30 comes from, and the adjacent side is radical 3 over 2, which is where the cosine of 30 comes from. So that's where those values come from in the table. If we were to look at this 45, 45, 90 right triangle, and I made it into a unit circle as well, making the hypotenuse here 1, that means each of these are the same, and if you use the Pythagorean theorem to solve for them, you're going to get both of them to be radical 2 over 2, which is where the 45s come from. So from 45 degrees, the opposite side, which is the sine of 45, is radical 2 over 2, and the adjacent side is also radical 2 over 2. And that's where all of the values on the table come from. If you have any questions, make sure you ask in the